Awesome, awesome. Okay, so far we've looked at, we started with talking about data, we talked about what data is, we looked at a couple of things, different data types. We talked about variables, we talked about the variable names, the values, we talked about Python being an object-oriented programming language. We even started talking about operators, conditional operators, assignment operators, conditional statements, and then we even came right down to loops. And then I think last week or was it the other week, we started talking about functions and we ended up creating our mathematics module. So that is how far we have gone. And before we step into the class of today and start looking at something completely new, is there any question? Is there any worry? Is there any challenge as far as what we've covered so far is concerned? If you have any question, any challenge, any problem, can you please indicate so that we can address it? So let's have the next 2 minutes to have that conversation. Anyone with any challenge? Is everything smooth? Mr. Okay, this one is the new person. Mr. Jamin, is everything okay so far?
Yes, Prof. Brother, so far so good. Prof, I think I'm going to recommend from your side is that I think if it's going to be possible after every class, please you give us some assignments so that we can, as assignments pertaining to the lecture of that day, so that even in the course of the week we can practicalize to make it stick. That's just a small suggestion from me. Thank you.
No, okay. Thank you very much. I get that. Any recommendation, any input again from any other person before we go ahead? Best man. I don't know if you talk French. Est-ce que ça va?
Oui, oui. Oui. Je comprends. Je comprends.
Okay, awesome. Okay, any other person with anything to add before we go ahead? Okay, awesome. Thank you all very much. Okay, let's look at something. Okay, when we started, we talked about different data types, right? So today we are actually going to be picking the data types one after the other and looking at them. But before we start, there's something I want to tell you that is very important. You know, in Python, we are going to see something that we call fundamental data types. Fundamental. If those people who know big English, fundamental, people with big English, we have fundamental data types, and then we also have what we call collection data types, right? So DDT. Okay. We have what we call fundamental data types, and we have what we call collection data types. Okay. Fundamental, the people who know big English, another word I know is called something like fundamental is something like basic, please. Dr. Kemfwa. Am I correct? And Madam Constance and all the people. Fundamental means basic, like foundational. Huh?
Yes, the basic, the core.
Yeah, good. So the fundamental data types that we will see constitute, there are three. Let me just say, not three. Let me just say you have what we call the integer, which is int, right? We've seen this. There is float, right? The float data. Oh, can you please help? Let me join this class from another device, okay? Because it's going to be challenging for me. I'll have to email that link to myself. So then I wanted to use my tablet so I can easily write, but I'll fix that later on. Okay, there's what we call the float data type. float is a fundamental data type. Then we also have, I think a string is also a fundamental data type, right? And then we also, maybe Boolean too is fundamental, I don't know, but I don't know about this one. Bool is also a fundamental data type. But now, these are fundamental, like how the madam has clearly explained, these are like the core data types, we call them fundamental data types. Now, when we come to the collection data types, we have things like, you have something that things like a list. We're going to look at all of this, okay? You have a list, tuple, right? Tuple, you have like dictionaries, sets, and all those, right? Dictionaries, and then sets and all those. Now these are fundamental data types and collection data types are the different types of objects that we can create in Python. So in essence, what we are saying is that a collection data type will constitute fundamental data types. Like you use fundamental data types to build collection data types. Just from the name collection means you bring together multiple things to form that type of data. And so we have fundamental data types and we have collection data types. Now, getting into the lesson of today, we are going to start looking at one of the fundamental data types, and which is the only one we are going to pay attention on, because that's the only one that might have a lot that we can look at, and that is going to be the string. It's a fundamental data type. We will not look at integers and floats because they are just what they are, the normal numbers that we use. And bools, they are just what they are. But we are going to pay some close attention to strings because there are some extra things that pertain to strings that we need to know. And they are very important. And so like today, we are going to start looking at that particular fundamental data type that is called a string. What is it? How can you create it? And how to manipulate it? Is that clear? And the talking partner, the first person on the list, her name should start with A. That is Madam Aqua Constance. Madam, can you be my talking partner tonight?
Yes, sir.
Okay, awesome. So did you understand what I said about fundamental data types and collection data types?
Yes.
Okay, great. Okay, now let's look at, we're going to be looking at the string today, which is one of the fundamental data types. We're not going to look at integers and floats and kind of thing, but we're going to pay attention to strings because as we go down, as we proceed, you are going to see some peculiarities that pertain to strings. Okay. Now let's look at this is supposed to mean it's a data structure. A string is a data structure which holds textual data. I just call it textual. And this textual is supposed to be in quotes. Sorry for that. My internet just decided to disgrace me in the midst of an important lecture like this. Can you imagine? This is disgraceful. But I know you all understood. Okay, let's proceed. We were talking about, can you all hear me?
Yes, we can.
Madam Constance, can you
Yes,
hear me?
Prof.
Can you all hear me? Can you see my screen?
Yes, Prof.
Okay, great. Okay, sorry for that interruption. Let's so we were saying it's a textual data type, and I was saying textual because I'll explain why I said textual is supposed to be in quote. because I just use textual to in the context of making it clearly understandable so that you can actually picture what I'm talking about. But as we proceed, you are going to see what makes a particular object a string. It's not about the fact that it's text or whatever, but we are going to see what makes it a string. So, but let's just use textual in this context as to mean they behave like the letters of the alphabet. Let's just use it in that context. Now, how do you create this string? This data or this object, this data type that we call string, or this object that we call a string, how do you create it? Now, the first option is you can create it using single quotes. Single quotes. Okay, let's see what we are talking about. I want to create an object, and I want this object to be a string, right? And so I can call my object anything. Let me see. I can call my object S. Okay. S is supposed to be a string. It can be anything, right? Okay, let me give an example of a string. It can be a name called Peter. And so now, I said to create an object that is a string, I need to use single quotes. So how do I use single quotes? I'm just going to press single quotes, open and close, and I type Peter in that single quote. Now, what I have done is I've created a string object called S. And the value of that string object is Peter. So if I execute this and I ask what is S, they say S is Peter. If I get the type of S, they say S is str. This is the short form for string, str. It is a string. So string is a type of object and it's a data type, and it's what makes it a string is the fact that you wrap it in quotes like this. So you can create it using single quotes. That's the first way to create it, right? Now, what is the next way you can create it? The next way to create it is using double quotes. You can also create it using double quotes. So let's see. Let's see whether if we create another one called S1, and then we use double quotes. This time around, let's call it John, and we're putting it in double quotes like I just said. I'm going to put John here. And if I execute this, and I ask what is S1, they're going to tell me S1 is John. And if I ask what is the type, if I ask what is the type of S1, and I'm going to get S1 is str, which stands for a string. So we have seen two ways through which you can create a string object. One, using single quotes. Two, using double quotes. Let's proceed. We can also create a string object using triple quotes. We can also create a string object using what? Triple quote. How do we do that? So let's see. If I want to create the third object, maybe it's S2, right? And I'm going to say this one is going to be Mary. So what I'm going to do, they say triple quote. So see, look at what I'm going to write. Are you seeing? So I have triple quotes, so I'm going to write Mary in quotes. So if you notice, there are three quotes here. There are three quotes here, and there are three quotes here, right? So this is an example of a string. If I run this and I ask what is S2, if I run this, I get that S2 is Mary. And if I ask what is the type of S2, I'll get S2 is a string. This is the third way through which we can create a string object. The third way is using triple quotes. So now, the last way to create a string object is using the string constructor. Is using the string constructor. What do I mean by using the string constructor? For example, if I say S4 is equals to, for example, let me say 10, right? If I run this, if I ask what is the type of S4, if I ask what is the type of S4, Python is going to tell me S4 is an integer, but I can use the string constructor to create a string. And I can say that S5 is equals to str. This is what I call the string constructor. This thing like this is what I refer to as the string constructor. Str in brackets. That is the string constructor. So in bracket, if I say str S4, that means I am now creating a string and then if I ask what is S5 and I pass the bracket, it's going to tell me S5 is 10 now. The 10 now appears in what quote? If I ask what is the type of S5, for example, and I run, it says it's a string. So I've created a string using 4 different methods. 1, I use single quote. 2, I use double quotes. 3, I use triple quotes, and the last one is using the string constructor. So in that same line, I can just say S6, for example, is equals to, I can just directly use the string constructor on my number, and I say SCRM, sorry, SCRM, maybe 12, for example. And if I return the type of, if I print S6, and I print the type of S6 type of if I print the type of S6, that should give me, if I run this, it says str is 12 and is of class string. So we have created string objects, and these string objects have been created using 4 different methods. 1, single quotes. 2, double quotes. 3, triple quotes. And the last one is using the string constructor. That is how to create a string. Madam Constance, any question? Any question? Any wahala?
No, Prof. It's okay. No wahala.
Are you talking for everyone? Everyone, is it okay? If you have a problem with what I've said, please. If you don't have a problem, still come. If you want to add, still come. If you want to subtract, still come. So let's wait and see. Any addition, subtraction problem, no problem? Okay, no problem. Okay, I'm getting a thumbs up, meaning everything is good. Okay, let's see another thing. Okay, now the next point. So now we have created our string. We have created our string. Now you know what a string is, right? And you know how to create it. Now, let me explain this thing when I said it is textual, and I was telling you that this textual is in quote. So, do you look at something here? This 10 is not a text, but I can convert it to a string, and I ask what is the type of this 10, and they tell me it is a string. That is why I said textual in quote. So I'll go back to reiterate on a very important concept that I said, or a very important statement that I made, that what makes this object a string is the fact that you either wrap it in this inverted commas like this, or the fact that you use a constructor to convert it to a string. That is what makes it a string. It's not because it's a number or it's a letter or whatever. No. The moment you see anything in Python that is in quotes, whether single quote, triple quotes, double quotes, or whatever, it is a string. That is how to denote strings. If you see it wrapped in quotes, that thing becomes a string. So if you wrap a number in quotes, that number is a string. And when we go ahead, you notice that the moment you wrap something and becomes a string, the behavior of that thing automatically changes. The moment you create an object as a string, the behavior of that object changes. That object now starts behaving like somebody from a different land. So that object becomes something completely different. It behaves differently. We are going to see that as we go ahead. So you can keep that statement inside the freezer, and you're waiting for me. When I go down, you ask me, hey, Prof, what did you mean by it will behave differently? And then we have a discussion there. Let's look at something now. How to take a string from user. We've been doing this a lot of times now. Shibi? Dr. Nkefwa, please, can you come on and tell me how to take a string from a user? You remember the last time you sent me a troubleshooting something. Are you there? Was it you? I'm sure. Dr. Kefwa?
Yes,
Are you there?
I'm there. Yes, I'm there.
Are you the one that we troubleshooted something on using the input function?
No.
Oh, no. I sorry if I did not identify the person, but I did that troubleshooting with somebody, one of the students gave to me. It should, now I'm forgetting now. There's a lot of students that get to me now. I'm just forgetting exactly. If you are the one, please, can you come on mute and let's have a conversation? I remember you used print in the place of input. And after we corrected it, you said you'll never forget. Oh, the person has disappeared. Okay, now let's see how to take a string from a user. So the function that you use to take a string from the user is called the input function. The input function. This function is used to take a string from the user. If you remember, when the day I introduced this function, I told you we were going to come back to it. But I said by default, the output of this function is a string. Regardless what you pass to this function is going to return a string. If you pass a number to this function, it's going to come out as a string. So the output of this input function by default is a string. Let's see it. So I'm going to say, I'm going to call it, let me say number. And I'm going to say number is equals to, I'm going to use input. And then I'm going to tell my user, enter a number, right? And once I tell my user to enter a number, I'm going to do, let me just run this, and then my user enters 10, for example, and then I execute this. So now look at, so if I ask what is number, right? If I ask what is number, Python tells me number is 10. If I ask what is the type of number, Python tells me number is a string. Did I explicitly put in quotes? No. Did I explicitly tell Python that this thing is a string, should be converted to a string? No. So by default, you see my 10 here. This is my 10. I've written my 10 here. It's not in quote. I did not write this 10 in quotes. I did not use str to convert my 10 to quotes. I did not. To convert my 10 to a string. I did not. I just said 10. See, let me show you. Maybe you think I'm lying. See, Lee, this is me writing my 20. Look at the way I've written my 20. My 20 does not have quotes. I've not used str to convert the 20 to a string. It's just 20. And once I run this, if I run this again, it says it's a string. So by default, the output of an input function is a string. So don't make that mistake. If you are going to take an input from a user and use it for mathematical operations, remember the default output of that input is going to be a string. That is how you take a string from a user. Unless you have another question, we are good to continue. Okay, no question. Let's continue. Now,
Please, don't to find out, does it mean that you cannot get any mathematical operation from a user?
you can, but you have to convert that input to whatever you want, because like I said, the input is automatically going to be a string. Okay, for example, if I don't want that input to be a string, we've done this before, right? What I'm going to do now is, if I want it to be an integer, for example, I'm going to now, this is what I can do. I can now say number. I'm just doing this for the sake of peace. I'm saying number now is equals to, I can explicitly convert number into an integer, so I can say number back. Yeah, sorry. I'm just typing things. So I can say number equals to number. I'm converting this. Okay, number 1. Maybe you're now confused because I've said number. Number 1 is equals to int number. Now, if I now can convert, if I now print the type of number 1, you see that type of number 1. Before I print the type of number 1, let me print number 1, right? Print number 1. So let me explicitly print number 1 and the type of number 1. So now look at what is going to happen now. So I'm taking an input from a user, and that input, I know that by default is going to be a string. So this is what is going to happen. I'm going to run this, and then I'm going to pass 25, and then I'm going to run this. and it now returns not 25, but now it says it's of class int. Why is it of class int? Because I explicitly converted it to an integer here. We are going to, I think we should do typecasting, but we'll do typecasting after we finish all the other data types. But this is called typecasting, where you can change from one data type to the next. It's called typecasting. So you have to explicitly change to an integer here, like this. The another way you can do it is to avoid typing all this nonsense thing like this, is to do this. Because this, you will never see me do this again. I'm just doing this for the sake of peace so that you understand. You'll never see me do this again. So what I will just normally do is that once I'm taking the input from the user, I'll explicitly convert this input to an integer here. This code like this is the same as this one. And then if I print the type, if I print number and I print the type of number, use the type of sure. Print, hold on. If I print the type of number, yeah. So if I run this, I'm gonna get my number 30. And if I print the type of number, it says it's of class integer. I did not have to write this line of code again. Like best man will tell you, it's redundant. I have to be typing the same thing over and over, so I can't explicitly change this from here. So you'll never see me do this again. You always see me do this, okay? So I can change it to a float. I must not be an integer. I can change it to a float, right? I can change it to a float, anything. And if I run it and I say 20, if I run it, it gives me 20.0 and I say it's of class type float. So it can be anything. It's up to you. Is that clear, ma'am?
Yes, understood. Thank you.
Okay. So now let's continue. So we've learned how to do that. Can I also create an empty string? Yes, I can create an empty string. Oh, I can create an empty string. Of course, yes. I can create an empty string. So how do I create an empty string? If I'm saying that my S is equals to, if I just do this, this is an empty string. It's an empty string. This is an empty string. If I print S, if I print S and I print the type of S, if I print the type of S, right? It says it's of class string. It's an empty string. It can be this. It can be this. It can be this. Oh, sorry. It can be this. All they are the same. This is an empty string. Is that clear? So you create a string without anything inside. It's an empty string. So that is an example of an empty string. So if I run this again, you see it's a string of class, it's of class string. So yes, you can create an empty string. If you had that question in mind, the answer is yes. Okay, now there's something we are going to look at. This is extremely very important. So if somebody was tickling you, you can tell the person down to wait in the kitchen while you finish, and then you can call the person to come back. So this is very, 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 very important. This thing that we're about to do now, like this one is extremely important, and it's going to cut across all our lessons. I'm not going to repeat it again. So please tell all your distractions to shift a bit. Let's look at something. I'm going to create a string. I'm going to create a string called S, and I'm going to say my string is equals to, I'm just going to create it. I can create it, or I always like double quote. I'm going to create my string called happiness. I don't know if this is the spelling of happiness. Happiness, yes, let me use happiness. Now, I'm going to create a string called happiness. I'm going to run this. Please, I want you all to pay close attention to what I'm showing you now. It's very, very important. It's going to cut across everything that we are doing. From every data type, we're going to see these concepts come into play. Okay, now, I'm going to explicitly write out this happiness out here, happy. And I'm going to put some spaces. Why did I even choose this word there? That is having a lot of letters repeating like this. But since I've chosen it, let me just work with it. Okay. Now, If you remember the last time I told you guys that Python counts starting from 0. Python does not know that the first number is 1. No, the first number according to Python is 0. So this string has some positions or something associated to it. It is called indexes. They are called indices. It's an index. This is H is at position or index 0. A is at index 1. This first P is at index 2. Second P is at index 3. This I is index 4, 5, 6, 7, 8. So this is in terms of position, and they are called indices. So this is index 0, 1, 2, up to 8. And I can also name these indices in a reverse order. And in that reverse order, it is going to start from -1, -2, -3, -4, -5, -6, -7, -8, -9. So what I'm saying is that 0 is the same as -9 in terms of index for happiness. So the position of H is either you use 0 or use -9 as the position. If you are using negative indexing, it is -9. If you are using positive indexing, it is 0, 0. Don't ask me why there's no -0. I do not know why. There's nothing like -0. So you could announce, you want to ask me that, Prof, this one ended at 8. Why is this one ending at -9? Because there's no -0 now. So instead of, so you start from -1. That's why this one did not start from 0. So there's nothing like -0. Okay. I hope this is clear. Okay, now look at something. Why is this very important? Let me show you something. Looking at this string, I can decide to pick the first letter in this string. I want to output the first letter in this string. I want to output the first letter in this string. Look at what is going to happen. I'm going to say S. Look at the syntax I'm using. You are not choosing your syntax. I'm going to say X and then I use square brackets. And then I pass the index of the letter I want to pick. I want to pick H, and so I know that my H is at index 0 if I'm using negative indexes, so I put 0 inside the square bracket. And if I execute this, I'm going to get H. Okay, now you are thinking that, okay, Prof, you also said it's the same as -9. Okay, oh yeah, let's see what -9 will give me. I'm also going to do X -9, and I'm going to execute this. It gives me H. Am I lying? It's the same thing. This concept is called indexing. I can say I want position -1. If I do S of -1, Madam Constance, tell me what is going to be my answer?
Your answer is going to be S.
Okay, let me see whether you are correct. Yes, you are correct. My answer is going to be S. And so if I say I want S of what? Of 3. Dr. Kemfo, tell me what's going to be my answer? Dr. Kemfo, are you there? What is going to be the output of S of 3? If Dr. Kemfo is not there, Dr. Kifa, you can help him. What about Madame Vandolin? Can you come and help them? The men, they are not responding.
P.
It's P.
Okay, let me see. I don't know whether it's going to be P. Yes, it is P. Correct. So you guys already know indexing. You already know indexing. So if there are 5,000 words here, you can actually pick their indices. Starting from 0 or starting from -1, you can go wayward. Now, this is the concept of indexing. What does it mean to slice? I've shown you how to index, Abby. What does it mean to slice? Let's see how to slice. Now, still based on this concept of indexing, if I want to pick more than one letter, maybe I want to pick the first 4 letters. What am I going to do? I'm going to say S, and I'm starting from what? Position 0, right up to. Hey, you see the way I write my right up to? My right up to, I use colon. If you don't know what colon is, go to your computer, you see some two vertical dots. The same button where you have semicolon. If you're using Windows, yeah, you have to use shift semicolon. Shift that button that has semicolon. You have there's another key up that's called colon. You use right up to, if I want to pick the first four letters, so let me count. If I want to pick the first four letters, let me count. This is 1, 2, 1, 2, 3, 4. What's that position index? 3. So I come and I say from position 0 right up to position number 3. If I run this, it gives me, oh, sorry, it's always n-1. I forget. Let me explain that before I come and put myself in trouble. I'll explain it. It gives me the first 4 letters. So what has happened is that if I want the first 4 letters, I have to do since it starts from 0, it's always the last number minus 1. So you say n-1. So it's always going to be n-1. So if my index is 3, I have to take 4 because the last number is always going to be n-1. Please take this very important. This is very important. The last number is always going. I remember we did this when we were doing the range function. The last number is always going to be n-1. So if I am picking the first 4 letters, 1, 2, 3, 4, but I want the first 4 letters, but instead of passing from 0 to 4, I'm going to say from 0 to 3, I'm going to say from 0 to 4 because the last number is always going to be n-1. Is that clear? This concept like this is called slicing. If I want now to pick the last, the last 3 numbers, what am I going to do? So I'm going to do what? I'm going to do S, the last 3 numbers, right? So the last 3 numbers are going to be starting from what?
Yes.
-3, right up to what?
6.
You can either say right up to -1. This one you don't do
-1.
n-1. Yeah, and so when you run that, it gives you, yeah, this one, I'll prefer to do it like this. Let me show you. Right? Now, okay, now I've done something here. Now, let me explain what I've done. If you do not specify, okay, let me show you something before I explain. If I just say, for example, if I say, let me use positive indexing before I go to negative indexing to explain this concept. If I say if I just say, for example, if I say I want S position number 0, and then I put colon, and I don't specify where I'm ending, it's going to pick all these numbers, all these letters. If I just say starting from 0, if I put only the start, because this is going to be the start and this is going to be the end. If I specify only the start and I do not specify the end, it's going to pick every other letter or every other index after starting from the beginning. And so if I run this, see what is going to happen. It's going to return the whole of happiness because I've started, but I've not specified the end. You understand?
Yes, it's understood.
I've started, but I've not specified the end. And it also applies. If I want the numbers up to a particular number, for example, if I don't want these last 4 numbers, I can also do S, and I say I want all the beginning numbers right up to what? Position number, what's that? Is it 5? Let me try 5 and see whether it's going to return me. So if this thing works, I'm expecting HAPPI. I don't want NESS. I don't want that. So let's see. You see, it's the same concept. If I want from the beginning to a certain number, I start the beginning blank up to a certain number. If I do not want a certain number, I don't pass it. So it's easy for me to say if I want the first, because it will always be easy for you to say, hey, can you give us the first 5 students? The first 5. It's easy to say the first 5 or the last 10 or the last 20, right? Or the numbers between 10 and 15, something like that, right? And if I just want to have INE, if I want just INE, I'm going to have S position. What is my I? My start is on position number 4. And then I'm going to put my column and then my position number NE. So I'm going to say right up to INE. So it's going to be 7 because I'm going to be using N-1. And if I do that, it gives me I and E. So you specify your start and you specify your end. And so in the concept of negative indexing, right, I can also say S like this one that I did over here. So I can say I want the last three numbers. The last three numbers. So I can say I want the last three numbers. So I'm going to do S. I take -3 as my beginning, and then I don't specify an end, and it's going to give me from -3. So looking at our this thing, where's -3? This -3 will be E. So from -3 right up to the end is going to give me my number. So now I'm going to do this. Run this, and I get ESS. As well as I can say I want the numbers. I want the numbers excluding the last three numbers. I want the numbers excluding the last three numbers. So in that same line, I can do S, and I'm starting from my beginning. I put my column, but I do not want the last number. So I'm just going to put my -3 here. And once I run this, I assume it doesn't give me that. It's going to give me, yes. It doesn't give me ESS. So it gives me all the numbers right up to -3, but not including -3. This is the concept of indexing and slicing. Now, there is the third factor that comes in called step size. There is a third factor now that comes in. I've shown you how to index and I've shown you how to slice, both negative and positive. There is another factor that comes in that we call step size. How does the step size work? Let's see. Let me start with positive. I can say I want S. So I can come and say I want H. I do not want A. I want P. I do not want this other P. I want I do not want this N. I want E, and I do not want this S, and all of that. Look at what's going to happen. So I'm going to do this, and I'm going to say I'm starting from 0, and I'm ending at 9 because it's always N minus 1. And if I give it a step size of 2, look at what is going to happen. It gives me H, it skips A, it gives me P, it skips this other P, it gives me I, it skips N, it gives me E, and it skips this S, and it returns this other S. So step size, like if you remember in our range function, we talked about the step size before. It's like the way it skips, or it's folding, or jump. It steps to jump, right? So it skips certain things. And so in that same line, by default, if I do not specify the step size, my step size is 1. That's why if I just say S, if I do this and I do 0 and I do up to 9, for example, if I do not specify the step size, notice I've not specified the step size. So if I run this, it gives me everything because it's 1. But if I specify the step size, it now becomes another thing now. You can also specify a negative step size. You can also give a negative step size. So if I want to a negative direction, look at what is going to happen. If I want to print this thing in a negative direction, I'm going to say S. And then now, if I'm printing it in the negative direction, what I'm going to do, let me just try 0 to 9, and then I give a negative direction just to see whether it's going to work. If it doesn't work, then I'm going to swap it, okay? -1, I just run this. Oh, it gives me an empty set because it's out of range. Correct. I expected that too as well. So what is going to happen is that it's going to give me from 9 up to 0. And if I run this, it gives me the opposite. Yeah, this one is not giving me, it's, I can key this one because it's killed out H because it's always N minus 1. So if I run this, it gives me everything in the opposite direction. As the same way I can do this negative indexing using the negative concept, right? I can use S, and then I say instead of starting from I can now say I'm starting from -1, right, up to negative -10. I think that should be the case, and then I'm giving a step size of -1, right? And if I run this, it gives me the same thing in the opposite direction. I can also do a negative step size of 2, of course. Then do a negative step size of 2, right? If I do this and if I pass 2 here, I can run this and it gives me the same thing in an opposite direction, right? The same thing, but in the opposite direction.
Okay, with the negative step size of 1, with the negative step size of 1, even if we don't specify, it will still come out the same, right? Since it's -1.
I do
We
not
just
understand the
say
question. Can
S -1, negative. If we I'm talking with respect to taking a negative
just tell me
step
what you want me to
size
type.
of 1. That
Tell me what you want me to type. S square bracket. Tell me what you want me to type, and then let's look at it.
S, yes,
-1,
-1,
-1.
colon
So I have to
minus
go
10,
up to, okay, -10.
-10.
So if I run this, it returns me an empty string.
Why?
Now you're asking me why it returns an empty string. Now let's look at the beginning. Where is the beginning? Where is the beginning? This is the beginning. So if
Beginning
you
of
see for where is this thing? Where is the start? Where is the start? This is the start, right?
-1.
Yes.
Yes.
And if you do, I told you that if you do not specify a step size, by default, the step size is 1, not -1. So it's going to start
Okay.
from 1. When it starts from 1, what is going to happen is that it's going to add 1 to -1. And if you add 1 to -1, obviously nothing returns, right?
Nothing returns. Okay.
Yeah, because
Understood.
if you look at this is where we are standing. This is where we are standing. This is -1. This is where we are standing. And so if I add 1 to this, it becomes
Yes.
0. But it's not like you can skip and come and stay. No, it doesn't work like that. So it has to be serial. But if I add -1 plus -1, it's going to give me -2. That's why it will move from here to here. If you add -1 again, it moves to here. Add -1 again, it moves to here. Add -1 again, it moves to here. You understand?
Okay. So
Yeah. But if I do not specify my step size now, it takes -1 plus 1. It gives me it gives me 0. But it cannot look at where it is. It's a forward movement because -1 means backward movement and 1 means forward movement. So if it stands here and you say -1 and then it says, and then it adds 1 to it, it's going to take a forward step, but there's nothing to pick. That's why it returns a negative string. Is that clear?
Please, Prof, can you hear me?
Yes. Yes, I
Yeah.
can hear you, sir.
Please, Anthony, please, can you explain how manage 092 translated to HPIES? I didn't get that very clear.
Where is 092? Can you tell me this one, this execution number?
Yes.
Okay. Okay, good. Let's calm down. So what is the start here? You tell me the start. Okay, where's index 0? What letter corresponds to index 0?
H.
Okay, so do we have H?
Yes, correct.
Okay, so it picks H. So what next? Where is it ending?
Come again, please.
So this is 0, 1. Oh, let me write it close. Oh, wait, hold on. So this is actually 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. So now, we are starting from 0, right? And you say 0 is H, right? So we already have H. Is that clear, sir?
Yes.
Where are we ending? This is our start. What is our end? Where are we ending? We are starting from 0.
Yeah. Mm-hmm.
And we are ending at 9. And I said 9 because it's always n minus 1. So if I'm putting n minus 1, that means if I take n minus 1, so if I take 9 minus 1, that means I'm ending at 8. The
Oh,
n
okay.
is always n minus 1. So if I take 9 minus 1, that means I'm ending at 8. And if I'm ending at 8, this is where I'm ending. You
Okay.
understand?
Yes.
So that is why I have 9 here. So if I'm ending at 9, that means I'm starting from H to S. Right?
Mm.
Are you getting me? So I'm going to
Yes.
write my beginning and my end. So I have my S here. Right? But now there's another thing that comes in. There's a 2 here. And I explained that this 2 is a step size. It tells you a jump. This means if I have a 2, that means after you write the first letter, you have to jump. And then go to the next one. So if I write A, H is, if I put 2, it jumps. So it's going to jump. Boom, it's going to jump this guy. So where does it land? P. It's going to jump. And once it is on P now like this, it's going to jump again. It jumps this other P and land on what? I. It jumps from I, it jumps
I.
and then N and land on what? E. And once it jumps on this S and land on this other one. So we end up with H, E, I, E, S, just like you have seen here.
Oh, I see. I see.
So if I had put a step size of 3, it would have been jumping 2. It would have jumped this one and so let me see. Let me show you. No, I don't want to clear everything that I've written. I'm tempted to just come and wipe. Okay. So if I put 3 now, let's see. Let me show you. If I put a step size of 3 now, let's see. So let's copy this. And instead of 2, let's put 3. And if I put 3, it's gonna look at what it's gonna come out. So let me show you how this happens. Now it starts from where? From H,
H.
right?
Yes.
So it's going to start from 0, which is H. Then our N is what? N minus 1. So it's going to be what? 8, right? So let's see.
Yes.
So let's see. So it starts from 8. So it starts H. It jumps 2. It jumps. So it's going to jump this and this. So it lands where? Here. So we have P. It's going to jump 2 again. 1, 2. So it lands where? Here. You have
E.
E. And it's going to jump. So now when it jumps 2 again, 1, 2, it lands on nothing.
Yeah.
So that's why we only return what?
HPE.
Is that clear?
Oh, wow. Makes sense. Makes sense. Yeah.
Any other question? Any other worries? Any other
Thank you very
challenges?
much. Yeah, thank you.
Yeah, my pleasure. My pleasure. Shebi, una no wan ask question.
Then for the negative, could you take it
Yes.
again?
For the negative, yes. Ask the question about the negative.
Yeah, the negative step wise something like that's -1, -10, minus using this same example, using this happiness.
If I want to do -1, the only idea is that by default, if I do not pass a step size, it's not keeping anything. It will just move H, A, because the step size is 1. So it takes H, 1, boom, it lands on this one. 1, boom, it lands on this one. So, but if I say negative, it means I say go in the opposite direction. I told you, if I say positive, it goes in this direction. If I say negative, negative goes in this direction. You understand? And so, if I want to go in the negative direction, I have to indicate where I'm starting from, my start and my end. And so my start, in most cases, in the negative direction, your start should be bigger than your end.
Okay.
But in the positive direction, normally your end is bigger than your start. Look, if you know small mathematics, you understand that -1 is bigger than -10. You know that, right? This is it's a fact. Okay, -1 is bigger than -10. Once you add this negative to negative 1, 0 is bigger than minus 1 million. This is the
Yes,
number line
correct.
now. If you draw the number line, like this, this is where you have 0. This is where you have negative 1, negative 2. As you are going to this direction is reduction. You are reducing. If you are going to this direction, you are increasing. Right? So this is 1, 2, 1, 2, 3. So if you are going to the left, is you are reducing. So any number to the right is bigger than, even if I have 1 million here, any number to the right of this 1 million is bigger than this 1 million. So 0 is bigger than minus 1 million. That is a fact in mathematics, okay?
Yeah, sure.
Yeah. So now, that said, if I want to do negative indexing, right? Let me just clear this. So if I want to do negative indexing, that same applies. So where do I start from? I start from my start. My start is what? If I want to do negative, I've said this negative 1, right? So
Minus
this
one,
negative
yeah.
1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and negative 9. So if I want to start from a start, like for this one, my start is negative 1. So I give it negative 1. Where am I ending? I'm ending at negative 10. Because why? Because I said the n is always n minus 1. So you understand? So if I say negative 10, it takes negative 9. So that's why it's ending here. So if I pass this, you see why it runs in the opposite direction. Negative 1 up to negative 10 using a step size of negative 1. Because I say negative means you are running in the opposite direction.
Yeah.
If you give a step size of negative, any negative, it runs in the opposite direction. It runs like this. It runs in this direction like this one. That's why you come, instead of having, when you give positive, it have happiness. When you give negative, you have something. Yeah, it goes the other way around. If you look, S here is the last number, but down here, S is first. This second S, second E, the same thing. It just reverses the thing. Is that clear?
Yeah, I'm following.
Yeah, that is how it's not different. It's just the same concept, but in the opposite direction. The same concept, but in the opposite direction. And if I give a step size of negative 2, it's going to be skipping like this. It skip this one and come to this one. It skip this one and come to this one. It skip this one and come to this one. And then just like that.
Oh, wow. Wow. Thank you very much.
But it's going to be doing that in this direction like this. Yes. You're going to be doing that in this direction. Any other question?
Okay, thank you. Thank you. I now understand it.
My
Thank you
pleasure.
very much.
My pleasure. Any other wahala? Any other trouble? Okay, now,
Yeah,
who
I
is
have a
coming to
question.
add and who is going to subtract? Okay, question. Okay, let's take question first. Oh, yeah. Right on.
Cell 44.
Cell 44, yes. Clear.
Yeah, I wish to understand why this minus 1 was to say that it should not include minus 1 at the
I
end.
don't understand
Minus
what you
1
mean.
is S in brackets. You have
Okay, if I
minus
do
1.
not include minus 1, is that what you're saying?
Yeah, the last minus 1 at the end of the cell.
This one or this one? Is it this one that is currently highlighted or this one?
Yeah, the one that's currently highlighted. No, the other one.
This one.
Yeah.
That if I do not include this one,
I'm saying, what
can you
does
ask your
that?
question now? That is the
Yeah,
step
my question
size.
is.
I said is the step size.
Mm,
Step size. Step. If you are walking, and I said if you are making short steps, if I say increase your step size, what do?
You increase.
You increase this your foot length,
Yes,
right?
exactly.
So by default, when you are indexing by default or when you're slicing by default, your step size is always 1. That's why if I do this, I get happiness, all of it.
Okay.
Because the step size here by default is 1. If I put 1 here, it doesn't change anything, right? I'll still have happiness. I still get happiness here. But the moment I change to -1 is something else. I said negative means I'm indexing in this, if I say positive step size, I'm indexing in this direction. If I say negative step size, I'm indexing in this direction. That's just the difference.
Okay.
Positive step size, I'm moving to the right. Negative step size, I'm moving to the left. Another thing is that when you're using a negative step size, your beginning is always bigger than your end. And not like that. It depends on the logic too. Let me not say, but for simplicity's sake, that's why -1 is bigger than -10, because this is the start and this is the end. But when it's positive, the start is 0 and the end is 9. Start smaller than end. But when it's negative, it's the other way around.
Okay.
It's the same thing like the positive indexing, but the only problem is that it does it in the opposite direction. The concept is the same. Is it clear?
Yeah.
Is the step size. If I change it to 2, because if I use 1, right? If I use 1, it doesn't skip anything. But if I do 2, it skip. It skip. It start 1 and then 2, right? If I do 3, it starts 1, 2, 3. If I do 4, it will start 1, 2, 3, 4. It skips. It's like telling me that instead of making short steps, can you extend your steps to skip like 4 steps? That's the meaning of step size. We saw this when we were looking at the range function. We saw this. We'll see this again when we are creating arrays. Is that clear?
Yeah.
Yeah. Maybe when we do more examples, you understand. Any other worries? Any addition, any subtraction, any multiplication, any division,
Yes, just to
any
add,
query? Okay.
this indexing, I don't know if we're going to come back to it. If not, let me just add that for indexing, there could be double indexing if the variable is more than 1. Let's say we have happiness and comma John, like it's in a list. That way we can double index, have happiness will form the first index, then the second object, which is a string joy, will form the second index. So you can double index. I don't know if you understand
Are you
me,
saying something like
Boris.
this? Something like this?
Yes, please.
Are you saying that you can double index here, here, and here?
So if you put them in a list,
Oh no, we are
not in
still
a
getting to
string,
list. Oh
not
yeah,
that.
I hear what you're saying. Yeah. If it's in the list, yes, you can double index. That's correct. That's correct. Yes. Go ahead. Sorry. Sorry. Go ahead.
So
I
that's just
understand
what I
what you're
wanted to
saying.
highlight. That's it.
Okay. Yeah. That's very correct. When we get to a list, I think we're gonna look at list. The very next data type, when we get to collection data types, we're gonna look at list and they'll see the concept of double indexing. That's correct. Thank you very much, best man. Yes, the concept of double indexing. We're gonna look at that when we get to this. But even wherever we are going to see indexing, the concept to remain the same, please. The concept to remain the same. The same thing I've shown you here. It's the same thing that's going to apply in any indexing we're going to be doing going forward. The only difference now is how do you apply the logic in that case? Is that clear? So let me give me a minute and digest what I've said. And then when I come back, we're going to continue.
Okay. Uh, how I wish I could be enjoying myself like this, like you now. But battery, oui, non, mon téléphone. Je sais même encore, ça peut encore prendre. Mon téléphone là, les deux.
Okay. I think we can continue, right? If unless there is any other person with another worry. Okay, if there is no other worry, then let's see the next thing we have on the agenda. So we've looked at slicing and indexing, which I said was very important. Now we can also iterate over a string, you know, using a for loop and a while loop. How do we do that? Okay. You can iterate over a string, right? So how do we do that? Let us see how to iterate over a string. So this is my string, right? My string, this is my string happiness. So if I can say, I can use this string and I can iterate over it. So let me see. So I can see for elements in S, I can print the elements, right? I can print out the elements. And if I run that, I get happiness, right? I've iterated through this element. I can even do this. I can even print elements times 2, right? If I say elements times 2, I multiply each element by 2. This means iterating over the loop, right? So I can even say, I can say for elements in this, instead of printing elements, I can say print good morning. Print good morning, and I'm going to get good morning. The number of times that pertain to the number of elements in. So how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 9 of these here. So this is it. So you can also do it for a while loop. You can see while sorry, I was supposed to initialize. So I can see I can start my I to equal to anything, maybe 0. So I say while I is less than or equals to the length of S. I know we've talked about this length function before. It just tells you how many number of elements. So for example, let me come down. If I say the length of, if I use length function as the length of S, look at what it's going to say. It's going to say there are 9 characters there. So it tells you how many elements are in this. So I can see while I is less than the length of S or equal to the length of S, right? Print in that same line, I can say print the same good morning, good morning, and I can, and oh, sorry, undo. And like we already know, we are going to say I plus equals to 1. When we run this, we have good morning. The same way we were expecting. So either ways, it's up to you. So we have used the for loop and we've used the while loop. So you can loop through it and do anything that you want to do. If you want to loop through it and perform a specific task based on the number of elements in your string, then go ahead. You can loop through and do anything that you want to do. Okay. I know this was easy because we've done this before, so it was straightforward. So let's look at arithmetic operations. Okay, now if I have, let me come back and just let me redefine my S. I'm gonna use my SC. Now, I'm going to make something very clear here, so that if I see S, see, this is my S. If I say S plus S, I'm using arithmetic operations. This is plus. If I run this, you get happiness times 2. So if you want to frighten people, you say this is called concatenation. You hear the big word, right? It's called concatenation. What you have done is you have concatenated. But for the sake of peace, since I don't know a lot of grammar, I'll say join. So this sign is used to concatenate strings, this plus. You have concatenated. That's why you have seen happiness and then happiness again, because it's S plus S. So I've joined 2 S together. I've concatenated 2 S together. So for the people who want to be, if you want to frighten people with grammar, it's called concatenation. And now I can say, like if you notice, you've seen me do that above there. I can say S times 2, right? And if I bring that, you see the same thing. As if I say S times 3, it does it 3 times. If I say S times 10, it's going to multiply it 10 times, you know. If you saw someone, when I did something up here, I said elements times 2. You were seeing it was printing the elements 2 times. Yeah. So it's the same thing, multiplication. So that is it. Okay, now let me show you something, that the fact that an element becomes a string means that it does not behave the same way you know it. If I say S is equals to 10, look at something, please. S is equals to 10. And if I execute this, and if I say S plus 1, and I run this, I get 11. But if I say S is equals to 10, now you see difference. And if I run this, if I say S plus 1, look at what I'm going to get. I'm going to get an error.
Error.
Why am I getting an error? Because this 10 and this one, they are not the same. Even Python can even help you. This one is green and this one is red. That is clear proof to you that they are 2 different data types.
One is integer, one is string.
Yes. And so the moment you wrap something in quotes, it starts behaving like something else. It's not the same thing, you know. So don't think that if you have your number, because it's wrapped in code, you can just go ahead and add it and multiply it and divide it as you care, thinking that it's going to work the same. See, if I even come here and I tell you, if I come and do S plus S, look at what I'm going to get. See, it's 10 plus 10, 100. What's this number? 110. It has concatenated the thing because it's now behaving like a string. It is a string, not behaving like a string. It is a string. Yeah? If I say S times 2, look at what I'm going to get. If I say S times 2. You see? So the fact that an object is a string, it's now, I can even do S and I pick 1. And it's going to give me 0. That's index 1 is 0, of course. Because it's a string. But if I say S is equals to 10, if I run this and I say S of position number 1, see what it's going to tell me. It's going to tell me, this boy, you're crazy. Yeah. If I say S of position number 1, Python is going to tell me, I don't know what you're talking about. You say you are crazy. Because it does not understand what I'm trying to do here. But it understood this one. So never you think that these 2 people, this man and this man like this, because you know that is 10, they are the same. They are not the same. In programming languages, these 2 people are not the same. They are not even brothers. So I hope that is clear. Okay. I've looked at arithmetic operations. These are the arithmetic operations we can do like that. You can only multiplication, you can only do division and subtraction. Yeah, does not work. Relational and logical operators for strings. All I know I already said this thing when I was looking the ASCII values, right? I know I said it. If I create a string, if I say S equals to boy, please, this is not anything related to gender, please. I'm not gender biased. Let me call this S1. And I say S2 is equals to girl, right? If I say S1 less than S2, see what it's going to return. It says true. It says true, but you know that these are letters. So how can you be saying boy is less than girl? But that's because I told you people that this thing is not evaluating this thing based on the fact that you are seeing that it uses what we call the ASCII table. I have shown you that here before. I've shown you the ASCII table. I show you guys the ASCII table, right? I showed you the ASCII table. So looking at the ASCII table now, if I look at boy, where is B? Letter B, small b, where are you there? 98. Where is small o? 101. And where is Y? 121. So if I take 98, 101, and 121, I put all of that together, I'm asking, is that less than, what is girl? G, where is G? G is 103, I, 105, R, 114, and L, where you there? And L108. So we put all of that together, it is true. The other one is less than this one. That is what that evaluation is talking about. That is what this evaluation here is talking about. It's not talking in the real sense of you being a boy and I'm a girl, and then they are saying that I'm less than you. So if I even check for equality, it's going to say no, they are not the same, right? So if I say S1 equal S2, right? You know, this is, I'm checking for equality, it says false. They are not the same. So those are relational operators that we are using, and like I explained, this is completely wrong. You cannot not completely wrong, like it's not looking at it as boy and girl, but it's just evaluating it based on the ASCII values attributed to each of those characters. I'll call them characters, not letters. I chose my words carefully, because if this was a dot, it would be something else. It will still be evaluated. Okay, that is it for relational operators. They all work the same, equal or greater than, equal to, all those relational operators. You can do that evaluation. That was just an example of how you can evaluate that based on relational and logical operators. So we can look at something like common functions. So when I say common functions, please pay close attention to what I'm saying. When we are going to be looking at these data types, anytime I talk about the common functions, I am talking about the functions that can work for strings and will work for some other data types. I repeat, when I say common, what does the word common mean? It means everyone can, everyone can use it, or everyone can have access to, or something like that. That's the meaning of something being common, like it's available. So when we say common functions, it means those functions that can work for strings, it will work for some other data types, and also work for strings. And some example is the max function. And in the same line, right, if I return happiness, where is the? And in the same line, right, if I say S is equals to happiness, if I ask the max of X, right? If I ask for the max of X, it's going to say it's S. Still, this max is based on the ASCII table, because if you look at here, S should be the highest value here that has, where you there? When 115. Every other value will be less than S on this ASCII table. H is less than S, I is less than S, N is less than S, E is less than S. So that's why when I say max, it returns S. Oh yeah. It's the same thing. Same concept. So we can do minimum, right? I think there's min, right? If you do min of S, it's going to return A, because A is the least. So we can look at all the possible we can look at all the possible common functions. Let me see the ones I put here. There's sum, right? I can no, this one is not supposed to work. How did I put sum here? Then we can have sorted. See, I can sort this thing. So if I say sorted, if I pass S, it has sorted this thing in. If I don't want this, I can. If I want in the reverse order, I can see. Comma. If I put shift up here, see, it's going to have this something called reverse equals 4. By default is 4. So if I change this to true, you already know what I'm doing, because you people know we've talked about functions. So if I change this to true and I run this, it gives me in the opposite order.
Prof, please,
so this one is ascending.
Is it sorting according to the ASCII table?
It's still, yes, it's still sorting according to the ASCII values, yes. It is still sorting according to the ASCII values. That's why you have SSS in this order. You have this. So this one and this one ascending, Abi. This one is what descending. Descending. So if you want to do in a descending order, you change this to true, because by default it's false. So you can also do which one is the other function. I can delete there's the delete function. Yeah. So I can do the length function, you know, run the length function. It's a common function. If I do the length of S, it's going to tell me there are 9 characters. I already told you that length means how many characters are there. And if I delete, let me just say S1, for example. If I use delete S1, I don't want to delete S because we might still use it, and I run it and I return and I ask what is S1, and I ask, it says name S1 not defined, but you know that there is S1 because I define S1 here as boy, but because I've used delete on it, it doesn't exist again. Is that clear? Any worries? Any challenges? Any discomfort? Even if you're having running stomach, you can still tell us that you are having running stomach. Eh? It's not only when you don't understand what we are teaching. Okay, let's look at something. Is going to only apply to strings. This is what we refer to as specific functions. So let's see them. Oh yeah, and for you to know those functions that are specific, you just have to print the directory of a string. dir, you have str. I told you string is denoted str. So if I print this, see, these are different functions. There are many. These are the different functions. I'm not going to treat all because I don't know all. I know the ones that I've used. So I cannot treat all. So, but I took the pain to explain all of them here. So there's this thing that I killed myself and I tried to explain all of them. So if we see, if we come here, the first one is capitalize this function. So it's a capitalized function. And so what it is converts the first character of the string to an uppercase and the rest to lowercase. So if I say, and this is an example of a code. So if I take this code now and I run it here, I can do this. Just the same way it was defined. Converts the first character of a string to uppercase and the rest to lowercase. This is an example of a code. And it returns this. Now let me show you something. Because this one is written like this, I could have also said S1 is equals to, let me just copy this thing. I don't want to type, okay? S1 is equals to Control C. I'm doing this because I want to explain something. And if I execute S1 and if I do S1 dot, let me just copy the function. S1 dot capitalize and I'm running it gives me the same results. So it's not the same, you must not have to type it out like this. Now, why do I explain this? Now, look at the way I've used the specific functions. I want you to pay close attention. This is my object. My object is S1. And I use S1 dot capitalize. Look at the way I use the common function. Look at the way I use them. Instead of using sorted S dot sorted, I use sorted and then I pass S in bracket. But in this case, it's the opposite. I do S dot capitalize. Oh yeah. Shebi, I hope you see the difference. Look, if I wanted to ask for the maximum value in S, if it were a common function, I would have used S dot max. If it were a specific function, I would have used S dot max. But no, that's not what I did here. I use max and then I pass S in quotes. But in this case of specific functions, I will use the object dot the specific function. This is how I learned this thing. Oh, that's why I'm showing you the same way. Because me, I used to confuse these things. Up until
I can understand you well. It means that when you are using specific functions, you have to put the dot, then you give the function. But if you are doing common function, you put it in bracket.
Yes, that's what I'm saying. Thank you. That's exactly what I'm saying. Let's see some other functions. I'm not going to go through all, okay? I'm just going to pick them at random. You can use this one, right? I like this one because they say non-overlapping occurrences. See, count. And then you have start. It also has an end. By default, the start is 0 and the end is known. So if I just run this thing like this, see. If I run this thing like this, it's going to count the number of ANs in banana. And if I run it, this is A and N. AN. AN. It occurs 2 times. If I change this thing to A, and I run it, it's going to give me a different value. There are 3 A's, of course, 1, 2, 3. I would have also said S4 is equals to banana. I'm just showing you people this because, and then if I can do it, S4 dot count, I pass what? A. Oh. Where is my group name coming? Count. So it's the same thing. There are many. End with returns true or false. So if I want to check if my if my string, so for example, let me come back. I can do this s dot end with. If I ask whether happiness ends with s or end with, and is it ends with or end with? Can be crazy English. So it says true. But if I ask whether happiness ends with J, for example, it's going to say false, right? Because you remember S, now you people are looking at me. Maybe you are thinking that I'm thinking S was happiness. So I'm asking whether happiness ends with S, and it says true, yes, it ends with S. And I can actually, I can actually do, see, I'm going to copy this thing like this. There's shift tab concept here. That gives you, let me wipe this one. If I do shift tab, see, let me expand it. You say there's a start. I can actually know where I want to start. Okay, still with the concept of indexing, right? And then there's a start, comma, there's an end, right? So, okay, let me see. Let me say ends with S, comma, starting from, so let's look at happiness. Let me say starting from 0, like starting from H, right up to, right up to this 0, this is right up to 4. And then, no, this S is supposed to be a string, okay? Let me not come out. So then I'm gonna run this and it says false. Why is it saying false? Because between 0 up to 4, this is 0 up to 4. There's no S there. That's the meaning of this thing that is here like this. And they are telling you that the output of this evaluation is going to be Boolean. Okay, I don't know, maybe it's alpha, it's ASCII, you want to check it's decimal, it's digit. You want to check if there are numbers there, it's numeric. They are there. So that you can I have example codes that I put there. So when you are looking at this thing, this file, I'm going to share this file with you. You can take your time and go through, because I'm not going to go through all these functions. There are too many. Its numeric says true. So, my people, there are a lot of them there. You can try them out. And this is, if you want to see them within Python, you use this dir function to print them out. So that's it. Do you have any questions? Anyone else? Are there any questions or anyone else?
No questions for me, no worries, just I'm tired. It's not going again. I don't know why.
Okay, it's clear. I understand. It's been a long day. Okay, we're gonna keep it here for today, and hopefully see you all in the next class. But before we go, somebody proposed something, and so I'm gonna put this in the chats, and we're gonna pick an exercise. Please, all of you should pick this URL. Don't tell me that you did not have it because I'm putting it in the chat. Copy it. And somebody can just pick it and put it in the class group too as well, please. Help me. Help a brother. Help a brother, help a brother. Where's that thing? This URL, please, all of you should copy the URL. Somebody should put the URL in the chat in our class group, the WhatsApp group. Best man, please, can you help me do that? Just pick the URL, paste
sure.
it in the
I'll do that on the WhatsApp group.
in the class group.
All right.
Yes, in the WhatsApp group, so that the people who do not have it here can have it there. Okay, now, one of our colleagues humbly made a request today that we should be having exercises at the end of every class. So it's not like I can actually be creating these exercises because it's going to be very, 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 very difficult. But here you have 1 million and not different exercises for Python, okay? So for example, today we treated what? String, Abby?
Yes.
Can you people all go down to here where we have string down here? There's this thing here called string.
Okay.
You see? It says Python string 113 exercises with solution. Please don't go and look at the solution first. It's going to confuse you because they might not have solved the solution the way we have solved it. Because let me tell you, there are 1 million and not ways to solve the same problem using code. It depends the way you were taught. So pick some exercises here at random. I'm not going to tell you pick this one or that one or this one and that one. There are a lot of them there. A lot of them. Pick anyone. Use it. Try your luck. Okay, let's just see. I'm not looking at this. Let's see before our next class, solve the first 5, 6 exercises. Okay, from 1 to 6. Try 1 to 6. I don't know. I've not looked at them. I've not solved them myself, so I don't even know whether I can do them myself. Try them, and if there are any challenges in our next class, we are going to meet. Is that okay? I'm not hearing yes, sir.
Sure.
No, only one person is saying sure. Is it okay to everyone?
Yeah, sure. It's okay.
Okay, awesome. So please, that's it. Thank you very much for letting me talk today and for sharing your knowledge with me. See you all in our next class. Bye-bye.
Bye-bye.